Okay, guys, welcome back. Let's start now. So, I was talking about outlets. So, we talked about Z score, G score. We talked about box plot. We talked about different techniques, and we talked about outlier treatment. Let's move to the next topic. That is data visualization. So, you want to see the data, how it looks like. Normally, when you make a scorecard, you want to make sure that data is not very strange in behavior. But if you had too many known events, which is more like data is skewed, in that situation, data will look like this, which you are already aware of. That we have very few events. Because of that, data had a very strange look. So we should expect a behavior something like this in the score also. This is a so we should expect similar behavior, the kind of behavior you see here. When you make a
Can you share your
scorecard,
screen because we're not seeing your screen actually.
I'm sorry, really sorry. So we are here. So when you visualize the data, you get to see the trend of the variable. Based on that, if there is a requirement like in the LGD model, you want to make sure that your variables look like normal, normal in the sense like normal distribution, because you have a requirement that your target variable is continuous. So you have different requirement when you make an LGD model, because there you want to make sure you can run linear regression and you satisfy the criteria of linear regression. But we don't have that kind of problem here. So we can look at the variable histogram and say that okay, this is how it look like. And then we look at the variable distribution to make sure that we know where there are missing values. So we have missing values here, 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 which we basically already had treated them. So this is data visualization. Then we talk about T-square test. T-square test is a verification tool for a statistical significance between categorical variable. Our target variable is a categorical variable. Then we have some categorical variable like repayment type, and there was one more variable which we have converted into numeric. So we want to see whether there's a good relationship between categorical variable and target, and we want to see the correlation. But what problem we are facing on our data is when we run this analysis, we have negative values. Because of negative values, we are not able to run the chi-square test. So we skip this test, but it's a good test. Any question? Okay.
Can you
So,
explain again?
okay. The chi-square test is basically to find the relationship between target variable and categorical variable. So it will give us an indication of the importance of a variable. If that variable is important, if that variable is not important, and IV comes less, we will ignore it. But if variable is important and IV comes less, then we need to find out what's wrong with the IV transformation. It is clear now?
Yes, yes. Thank you, sir.
So we'll talk about weight of evidence and IV encoding. So weight of evidence is basically measure the strength of a attribute in a variable. So the formula to calculate the weight of evidence is distribution of good divided by distribution of bad, and it gives odds of being good. When the weight is negative, it means there are more bad than the good. Trend must be logical when you plot the weight of evidence. For instance, to calculate the weight of evidence for this variable, we take the distribution of good, distribution of bad, and take the log of that particular odds. It gives us this value. And we multiply it by 100, which gives us 72.6. So this is the weight of evidence of this particular attribute of age. So all the variables need to go through WOE and IV transformation. And once they are transformed, we can see the WOE trend and we can see the information value to decide which variables are important variables. So this is example how we calculate the weight of evidence and information value of age. For instance, there are so many counts here, and this is distribution of all, this is distribution of good, this is distribution of good in percentage, this is bad, this is distribution of bad in percentage, and this is bad rate. Bad rate basically shows like bad divided by total distribution. So it shows the bad rate. So to calculate the WOE, we'll apply this formula: distribution of good, distribution of bad. This divided by this divided by this. Take the log of what that and multiply it by 100. It will give WOE. For information value, we will have WOE transformation multiplied by distribution of good minus distribution of bad, which means this value multiplied by this value minus this value, and it gives us WOE. So we will plot this trend, and we will basically see that this value is in specified range. Based on this two, we'll decide whether variable is a good variable or it's a bad variable, weak variable. So we do the grouping. Attributes with the similar WOE, they are put together, and they basically are adjusted for the business logic, especially for the low count group. For instance, here low count groups are 860. This one is low count. We can merge with anyone, but this is a missing category, so we did not merge because of that. And if you see WOEs are similar, WOEs are not similar, so we cannot group here anyone. As far as categorical variables, they will have their own partitions like categories, like 1, 2, 3, ordinal, or there could be nominal categories. So based on that particular partition which they already have, we will basically calculate WOE and IV. As far as continuous variables are concerned, uh, we will basically divide them in equally spaced 10 partitions and see how the WOE and IV comes.
Oh,
Yeah,
then I have
go
10
ahead.
questions here.
Yeah,
Can you go to the previous slide, the first slide of weight of evidence?
yeah, sure.
So if we get negative WA means the distribution of bags are more, right? Not the actual numbers, right?
Right.
Yeah. And second question is, like in most of the projects, I have seen, again, depends on client to client and modeler to modeler. Like most of them, like some of them, they use the WE variable in their model, and some of them they do not use. So what should be the better approach here?
Thing is, in case you are deciding to make a scorecard,
Mhm.
then you need to use WOE. If you make a PD
Not
model,
the raw variables, like WAE of age will use. I mean the WAE values of that particular age will use. Will not use the actual value, right?
thing is the purpose of WOE transformation and weight of evidence transformation or information value is you want to make sure that there is a continuity.
Mhm.
When there is a continuity and some odd value cannot disturb your distribution, which means
Mhm.
like value between 5 to 10. If value is coming like 9, it's in the same range. If value coming like 5, it's in the same range. So you're trying to categorize, you try to create a homogeneous group
Yeah.
within a variable. So once you
Mhm.
create a homogeneous group within a variable, then your model, which you will code in logistic regression, will be homogeneous in the approach. So idea is to create homogeneous groups and see how they behave in terms of trend. If trend is intuitive, which means
Mhm.
monotonic trend, and it's in
Mhm.
the line of business, then you decide to go with that particular variable. If you find that particular variable is not monotonic, then you drop that variable. It doesn't matter how good it is, until unless you can group something in attribute and make it monotonic.
Yeah. So in the model, like let's suppose like the x1, x2, whatever variables we use in the final the equation. So that x1 should be, I mean, age like variable or whatever the WE we get for age variable of that particular group. Let's suppose the WE of 20 to 26 is minus 72. So if we have a
So,
candidate,
huh, so
we have a,
you need to do WE transformation of the
yeah,
whole data, and
yeah,
then
yeah. That's what my question is. So and use that particular information into your final model equation, right?
right.
Yeah. Okay.
But
Thanks.
sir, one question on this. Don't you think that if we are replacing the actual values, which are a lot many, with the few WOE like 3 to 4, let's say if we have only 3 to 4 bins of age, don't you think it's like an information loss? Matlab, I want to understand.
It's not information loss. Let me show you something. 1 minute. Thing is, if you look at the monthly installment has this many counts, and that this very percentage of event, this many percentage of non-event, and then this is the value. If you see these values are similar, you will combine them. But there is no information loss because it's a continuous, which means from this value to 59.599 until this value, you have all the categories.
Yes.
So
So
how you
Siddhi, when you segment or when you make WE buckets of those attributes, actually you'll be covering all. So there will be one bucket of missing, I mean one level of missing, then 20 to 35. Likewise, till let's say less than 60 or 70. So I think even if a customer is, let's suppose a 60 plus customer comes in and apply for a loan or a card, obviously it will be a policy reject, because as per our policy we should not give a loan or product to a candidate or a customer who is more than 60 years. So I think we'll be in those buckets, we'll be covering all the age groups or all the variables. So I don't think that would be a loss for them. I mean,
So
information.
you will not lose any information, but you
Yeah.
will get the homogeneous group. These
Group,
groups are, these are homogeneous groups.
Okay.
So you create 10 group here because this is a big variable. You create another 10 group here, and you calculate the information value for each group. So I was telling you about dummies. When you create dummy, each subcategory becomes a variable. So when each subcategory becomes a variable, information value will be reduced. So that variable will be rejected automatically. So because of that, you don't create dummy when you create a logistic regression model, which is a scorecard. Make sense?
Yeah.
Okay.
Yes, thank you.
So coming back to this, so we will creating the groupings. Groupings will look like this. As I said, this is one group, this is another group, this is another group. And this grouping for continuous variable, you can create 10 categories or 12 categories, depending upon how you want to. Normally, they are okay up to 20 categories. But when you have 20 categories and you have similar WOE, then you need to merge them. Like for instance, these two lists should be merged, these three should be merged together. But they have not been merged because I make a quick and dirty model, which means it's working, but it's not perfect.
So the purpose of making homogeneous pools is that it will ensure stability.
Yes, it will ensure the model stability, and it will ensure that when some outlier comes, it can handle that.
Okay,
In that
because
particular,
the
in that,
outlier would come in any of the categories only.
yeah, it means like if you have these two categories, and when value comes to 55.599, that is one extreme. This is another extreme. This is not a good example. It could be a good example. This is one extreme. This is another extreme. So between these two, any value comes, it will fall in this category, and it will be a homogeneous group with this particular WA and this particular I information value. So if you change slightly the value when you use the row variable, in that situation, model coefficient will change when doing the model training. If you have some value which are not, let's say, good data, it doesn't represent exactly what basically you want to. In that situation, your model coefficient will be affected and your model will not be stable.
Okay, thank you.
So I talked about grouping. This is this grouping should be to take the outlier with the interval variable or for rare classes, and it should be in the format of the scorecard. When you do the formatting grouping like this, it helps you to identify the key risk indicators, and it's more than a simple statics. It's not just one coefficient. It gives a lot of information to you. It tells you if you are falling in this category, how many points you are going to get. If I open another one, where it is. So same data with the WOE, IV, and in score. So it tells you everything about this particular cutoff, this particular cutoff. It tells you the scores are coming similar, the behavior is similar, you can merge them. So that is another step which you need to take when you work on this model again. So you have homogeneous classes. If there are reverse trends, you can merge and you can make them smooth. For instance, in this case, you can merge these two also if you want to. You want to get rid of this particular reverse trend.
Sir, can you explain this point, model non-linear dependencies with linear models?
Monial node. So, okay, let me go next to the next slide. When you are here, this is a monotonic trend, right?
Hmm.
If you merge these two, basically you remove this point, line will be like coming like this.
Okay.
Same way if you remove it here, merge these two, one smooth line will coming here. So if variable is very important, you want to make it behave monotonic, just like this. So you remove the low linear way behavior, which is there in this one, and make it like this.
And also, I have one question that let's say beforehand some variable has a non-linear relationship only with default.
Right.
Is it required to have a monotonic trend then?
If you don't have monotonic trend, you will make it monotonic by merging the attributes. This is one attribute, this is one attribute, this is one attribute. So you will merge these two together, and then these two together, or these two together, make it behave like linear.
But
If you
why
don't have,
do we want linear relationship?
thing is, when you go to the logistic regression model, the relationship with the log odds as a linear relationship. Coefficients are multiplied by WOE values. They should be linear in the behavior.
But what if we are using some other machine learning algorithm?
If you're using some other machine learning algorithm like you use in the fraud, like you're using gradient boost or a decision classifier or
Yes.
random boost, in that case it's not required because accuracy is more important than using the model thing. Because you will not stick to one category there. You will use the best model which is there, and that model will come from the raw value of the variable. WOE transformation is not required because they can handle non-linear relationship. Like decision tree can handle non-linear relationship, random forest can handle non-linear, gradient boost can handle non-linear relationship. Same way neural network can handle non-linear relationship. So it's not required.
Okay, thank you.
Welcome. So I was talking about creating a homogeneous risk classes. So this is example of homogeneous risk classes here, which are created. And then when you have the homogeneous classes, it will basically create a stability in the model. There is something called reject inference bias. Reject inference bias comes when you have model where you're making model only on the accepted, but you don't have the rejected data. like we don't have the rejected data, we created a fake rejected data. So you need to fix the bias manually by looking at the data, and you need to make sure that acceptance rate is very close to total population, which means you are accepting 95% population, and there are hardly any rejects. So let's talk about monotonic trend. Monotonic trend means it's a line which is a more like a straight line. There's not up and down like this one. So it goes here like this. It goes up. It's not in multi-direction. It's in one direction.
So can you please explain that reject inference point again?
Reject inference point is like if you don't have rejected data, you need to remove the bias manually, which means there are some advanced techniques which I have not used so far to ensure that your acceptance rate is close to 100%.
But why would we need? Okay, so we ideally want acceptance rate to be 100%.
Everybody wants acceptance rate to be 100% so that you can do more business, even though there are some losses.
Okay.
Okay. So let me move to the next slide, which is talking about weight of evidence and information value. So weight of evidence is predictive power of attribute. There will be different range of WOE across different attributes. For instance, in this case, we'll have WOE varying from 0.6 to 0.197. So this is not only the criteria. You will look at information value also. If information value is greater than 0.1, it will be good predictor. If it's greater than 0.3, it's a strong predictor. But if it's less than 0.1, it's a weak predictor. So you want to make sure that you're taking care of WOE trend, and you want to make sure that information value is also higher.
I have one question, sir.
Sure.
So when you say the grouping of the WE values, so is it same as the course classing?
Yes.
Okay, got it. Thank you.
It's more like I made a quick model, but you have the code base. So with the code base, you can modify and do grouping of attributes. Let me go back here. So we did until here. So what we did here, like with the same maximum value, with the same minimum value, we had replaced, we had in the Winsorizing percentile capping. So you need to make sure when you do the percentile capping, if you do percentile capping on some value for the training data, with the same value, you need to do percentile capping on the validation data. Is this clear?
Yeah.
Okay. So let me go back and do the segmentation, try segmentation. So we will do the segmentation here. Like this is our training data set. We are dropping two variables. One is this one, another one is this one. If we don't drop this, let's see what happens. Let it be. Let's plot it.
Then what was the error which we got?
Shall we try again?
Yeah.
Okay. You need to be same variable in the both the places.
Mhm.
Okay, let's do it. So when you do this segmentation on CC util, you get zero default here, 724 default here. So all the default get transferred here. So when you have zero event, you cannot make model, right? Are you with me?
Yeah.
So we will drop this variable before we make the model.
But how do we know that we have to drop this CC util only?
Because CC util is creating problem here. If you do the segmentation on CC util, then we are getting something which is not working for us. Because we're getting zero event here, all the events here.
Okay.
So we drop the CC util.
Can we also try on some different limits as well? Right now, probably you are segmenting on less than 0.5. So if we will try on some other limits, then also, or do we need to check it to and fro?
Thing is, when you do the segmentation, best way to do segmentation is using decision tree. Decision tree gives you the best segmentation. So these two segments will be homogeneous in the nature. If you want to create homogeneous segment, you use decision tree or you use another technique which is k-means clustering. So decision tree is giving you this result, and you want to ensure that you have some events here, but you don't want to do it manually. If you want to do it manually, you can try manually, but there is no guarantee you will get the best segment. So
Okay.
yeah, the better way is using decision tree. Okay,
Thank you.
you're welcome.
Sir, does it also depend on which variable you are taking at the root node?
I don't take any variable on my own root node. This is automatic done by decision tree.
Okay. So you have feeded all the variables and then it automatically decides which one to take first.
Yeah, this is beauty of decision tree.
Yes. Okay.
So it has created the segment as seen in the slide on 2.6. So we create two partition now. One partition is on this, another partition on this. One is for less than, another one is for greater than. So let's do two partitions. We make a quick model without doing WOE transformation. So let's run it. So we got 430 event here, 430 event here. In another one, we got 294 event. So let's make model on segment one. So this model which we are making is, okay, let me go into this code. This is development sample. This is validation. Sorry, validation. We are using technique logistic regression, decision tree, random forest, gradient boost, SVC, k-nearest classifier. So we'll make a model here. Model is done. So it's trained here and it do prediction here. So while it's running, we will see that we have compared based on accuracy and ROC score. Coming back here. So ROC is coming 68, accuracy is coming 70. Now we build model on another partition. So we run it here on another partition. Run. $68 and this partition is 71. So we'll make a model on undivided sample. Are you guys with me? Are you following me?
Yeah, undivided sample as in overall population, right? Not segmented population.
Right. So
Sir, here then for each of the decision tree segments, there will be only 2 bins, right, for each variable.
no thing is we look here. We are making model on this data.
Yes.
We have made model on this data and we have made model on this data. So we are seeing whether if you partition it, it makes sense performance-wise or not.
So like area underscore months, we have matlab the decision tree has set a cutoff of 0.21, but this would divide the area underscore months parameter in only 2 bins, right? More than and less than.
Yes, because we cannot do partition here because we have less than 200 events here, less than 200 events here. So when we have less than 200 events, we don't do partition.
But what if we want a variable to have more than 2 bins?
If you want to have more than 2 bins, then decision tree have to give the output, right? If you want to do it manually, you have expert like knowledge, then you can do manually. But if you don't have expert knowledge, you use the statistical technique. In that situation, it will be more like this.
Okay, got sir. Thank you.
So we are making a model on undivided sample now and see whether there is a same performance or better performance. This is run. Now we're running on undivided. It's running. It has run. Let's see the performance. Performance is 70%. This is 70% on undivided. This is 71. This is 68. So if you take the weighted average of this and this, it will be approximately 69. While for undivided sample, we are getting 70%.
So undivided is you are taking raw values, right?
Yeah, with the raw values. But if you have time, you can do with the WOE transformation also. But normally you will do on the raw value when you do the segmentation testing.
But let's say we are replacing the actual values with WOE, then also we could have tested the accuracy.
We can do that. That's another option. I like that you make a suggestion. Normally we go back to the segmentation here. Normally you need to do two checks. One is AEC test, another one is approval test. So you need to make the full-fledged model until end and see what is the approval rate. If approval rate is improving, in that situation, you will go with segment test. But if approval rate is not improving, then you go with the total population.
So like I'm not able to understand approval rate. Like if you can show me through some example, like a bad rate I can understand for each of the bin for age variable less than 30, more than 30, we will have a corresponding bad rate. But how is the approval rate coming?
I'm showing it to you. We have somewhere here in the slide. So you will have plot like this. Acceptance rate and bad rate. So you will see whether acceptance rate can be improved from 80% to 90% or 85%. That's also a good improvement. So you plot this acceptance versus bad rate, and this particular graph is called strategy curve. It helps you to make a decision about the scorecard.
Okay.
These 2 points, one is this, one is this. These are potential cutoff points.
So this we do it at a portfolio level, right? Not at a variable level. Once we know the bad rate of our product, let's say, then we try to trace out the acceptance rate.
Yes, it's more like it will be on model level, not on the variable level.
Yes, yes. So we know the model level bad rate. We will try to find out the cutoff that will maximize the acceptance rate.
Right.
Okay. Thank you.
So go back here. So information value shows the power of variable, and WE shows the power of attribute of a variable. So coming back here, we got 70% here. Since we have limited time during this training, we basically have limited it to ROC cutoff. ROC is 70%. ROC here is 71. Here it's 68. But the 68 is on the big data. If you look here, this is a big data, this is a small data. It has 13,522 observations. It has 984. Here it's coming 71. It's coming here 68. If you do the sum of it, it will come approximately 68.5. But while on this one, it's coming 70 on the row variable. When you do the WOE transformation and IV transformation, it will definitely improve, but it's not sure that segmented will basically cross the AUC of total sample. So we decided not to do segmentation. Is this okay? Excuse me?
Yeah.
Okay. So let's keep this one. We found that ROC of segment 1 and segment 2 is 0.7 and 0.68. This is 70. We decided to build model on the full population. So this is chi-square test, which basically I was showing you. So if we try to run chi-square test, let me show you what happens. This is to see the relationship with the target variable of categorical variable normally.
You need to import from SciPy stats. You need to uncomment it.
Okay, sorry. Yeah. So observed value must be non-negative. This is the error which we get here. Because of that, we decided not to run the test because it has negative values. So we go back and comment it because it's not important. As long as you can do WE transformation, you're good. So next thing is we try to run the correlation. This is the correlation. When we see this variable like life status, repeat status, month, and there is one more variable which has this is the amount. This is the amount that's coming. Okay. There are some variable which we dropped based on this analysis. But this is coming NaN, which is a not applicable value. Okay. So based on this analysis, we had dropped these variables from this data. And we again run the analysis. So here it's coming okay. So we got rid of 3 variables on which we might have done additional processing in the next step. Where
You
we
said
take,
which all variables have you dropped? Those variables which are highly correlated.
no, which has not applicable value.
Okay.
Like this one,
Yes.
this one, this. So we got this graph here. We will drop it once we do the IV analysis. So we are here. When we run this analysis, we will get information value here. One of the variable has this IV value, which is greater than 1. So when we have this kind of situation, it will lead to overfitting. So to avoid this kind of situation of overfitting, we will drop this variable also, CCUT. And we will run this analysis again. Now we are okay. We plot this information value on this graph. We go back here. Our criteria is value should be greater than 0.01. If you have too many variables, you can afford that. If you don't have too many variables, you might include some variables which are weak in predictive strength. But in our case, we have a lot of variables which has value greater than 0.1. You look here. Like this one, this one, this one, this one. Until here we have basically variables. 1, 2, 3, 4, 8. We have approximately 12 variables which has information value greater than 0.1. So next thing we do is, yeah, go ahead. Next thing we do is, we do the WE plot.
Sorry, sir, to interrupt. I have one question here.
Sure.
So instead of dropping variables based on the IV value, like, is it also a good way? Like if I check the VIF or the variation inflation factor, and based on that, I check the multicollinearity, and I also check the IV value, and I drop based on that, like, would there be any difference in that approach?
Thing is, if you draw based on information value, and then you check the collinearity, then you have less variable to check the collinearity. Because you don't want to be in a trap where information value is less and collinearity is not there.
But would there be a probability that based on the IV value, I drop a variable which might have a less collinearity in the data? Like, is there any kind of probability if I do this exercise first, like dropping variables based on IV, then drop variables based on multicollinearity?
I think what you said is good idea. We will check that also. Just see. Just see. Just wait for 2 minutes. You will see that we are doing it.
Okay.
So this trend is okay for CCD dealing. This trend is okay for arrear status. This trend is okay for maximum arrears. This trend is okay for maximum arrear balance. This is only one dip here.
Right.
And then this arrear segment is okay.
Right.
Bus arrear status is also okay. And then maximum 6 months is also okay. And annual income is also okay.
Right. This is also almost.
This is almost fine.
Right.
This is almost fine.
Right.
But we have problem with this one.
Yeah, correct. Right.
We have problem with this one.
Right, agree.
We have problem with this one.
Right.
We drop all those variables which has problem.
But I think this is a weight of evidence, right? And we can create the monotonicity of the weight of evidence also. So I think by doing the course course classing, we can fix this, the monotonicity issue, right? And then we can include these variables as well.
Sure, we can do it, but I did not do it.
Okay.
Yeah, we can do it if you're making model in the professional capacity. You will try it. You will try it. But since we know it, I think this is good enough to understand that there's a better way of doing it.
Yeah, got it.
So we have this variable. After that, we will check the collinearity also.
Yeah.
Let's say, what are the variables? These are the variables with 0.1 greater than IV. In that, we are getting rid of couple of them. One is employment length. One is number of CCJ. One is remaining maturity. These three variables we got rid of it. This one, this
We are
one,
checking
and this one.
multi-collinearity also.
Yeah, we are checking multi-collinearity also.
So we are dropping all the variables in one go, or we are doing that as an iterative process basically?
We are doing it step by step.
Iterative. Okay. For at each iteration, basically, we are just looking at the IV value and VIF value, and based on that, we are dropping, right?
Yeah.
Got it. Sure. Thank you.
So coming back here, where I was. Here, okay. I have written this one. I have shown this to you. And then here, if I keep these variables, which are after filtering WOE trend, you'll see the collinearity. Let's do this one. Okay. And then we do the heat map again. In the heat map, you will see this value is high. This value is high. And this value is high.
Right.
We are trying to limit it to 70%. Ideally, we should limit it to 50% or 60% maximum. So we are trying to. These variables are correlated. Okay. So this one is dropped. This one is dropped. This one is dropped because of correlation. Correlation. Okay. So we dropped it and we put in the new data, D5 and D6. So let's run it again. Again, we do the correlation map. So we have maximum 71, which will again go down when we do the WOE transformation. Okay. So let's go to the D5 ahead now. And we are going to do the WOE transformation of the data. WOE transformation means you're replacing the row value with the WOE values.
Right.
So this is the code which basically I have written for this one. You can go through it. I think you have it. Okay, let me run it. So transformation has happened.
So can you please explain the code for any one variable?
Sure. Thing is, this is called binning. So for binning this particular variable, we pass the value of the bin. These are bins. This is the value of labels. These are labels. So based on these values, they'll be replaced by the label. So when you replace the bin by label, bins are based on this particular binning. You look at monthly sims. This is 1.9. This is 1.9, 4, 5, 6, 4, 5, 6, 8, 9, 11, 12, 13, 14, 20. So these are the values. I have exceeded this because of some problem. I was losing data.
And how did you get these bins?
These bins we get through this particular macro. This one. This will give this one.
You have specified bins is equals to 10.
Yeah, bins equal to 10. You can specify 20 also. Up to 20 you get okay. You'll be okay.
Okay.
Does this code or does this macro automatically convert a non-linear trend to linear? Like because in WOE we need, I think, monotonic trend. So does it automatically convert?
Thing is, for some of the variables like these ones, like this one, you need to do manual binning. Manual binning means if you want to make it monotonic, you need to combine these 2 points. You need to remove this point. Same way, you need to combine these 2 points, remove this point. So if WEs are similar, or you can do one thing here. Instead of putting 10 value here, you can put less values depending upon the situation of a variable. Are you understanding what I'm saying?
Yes, I think manual intervention is needed. I guess there are few variables which are automatically converted into linear trend, but at times we need to do it manually. That's
Right.
what I understand.
Yeah. That's what you need to do it.
Mhm.
So if you want to make it linear, you need to go here. And you need to combine the categories here. Like these categories can be combined. Same way you need to look at the how category can be combined for different variables. For instance, it shows non-linearity here. You can combine these two. So you need to look at the table, and when you do the transformation here, here you can merge. Here you can merge and you can put one value there, which is a higher value. This is also possible. So either you can play around here or you can play around here while creating the pins. You can do manual thing. Manual means you need to tweak this code and pass actually the bin value. Are you following what I'm saying?
Yep.
Okay. You can tweak this code. This is for you to play, make better model. Make better model. I'll be very happy. You can send it to me. I will have a look. So this is clear now.
Yes, sir. Thank you.
Welcome. One minute.
Sir, one question here.
Yeah.
So, sir, what would be the difference if I drop the variables based on the correlation matrix or the width?
Thing is, I had dropped three variable here,
Mhm.
based on the correlation matrix.
Right.
When I drop those variables, I don't need to do WE transformation for those variables like I have commented here.
Okay. Yeah.
So I can reduce my variables, but I want to make sure I have 8 to 15 variables.
Okay. Okay.
So if you look at here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 variables.
Okay. Yeah, 10. Correct. 11, I guess. 11.
11 is the 11th is target.
Yeah. Yeah, dependent. Oh, sorry. Yeah, dependent.
So let me go back here. Let me run it again. Sorry.
Mm-hmm.
I had done with this. I had done this. So let me do the WE transformation. WE transformation is here, and I had WE transformed here for
Okay.
these variables.
Uh-huh.
And when I look at the information of this particular data, I have original variable, then I have WE transformed variable. One of the variable which I have put on purpose is loan balance, which I have not dropped because I want to use the loan balance to calculate the EAD
Okay. Okay.
later on.
Uh-huh. Right.
So we look at the columns here, and we drop the NA and see how much data loss I have. I lost a lot of data. 1 minute. No. I have enough data. There's something wrong which had gone here. I don't know what happened. But data loss is happening. How much data I have? Just 1 minute. DF5, info. Let me check. I have this much data here. 14506. No, I do the WE transformation. This is okay. This is also okay. Let me see. I have this much data, right? My data is okay. Okay. Let me see whether I'm missing value for anyone. I am missing value for this one. Maximum real balance is maximum real this. Real income. If I say drop NA, not, let me not drop NA. Okay, fine. So I'll take only WOE transformation variable here. I'll say give me info about this now. So I have only WOE variable and target variable. And I'll do the correlation analysis again on this one. So my correlation is limited to less than 70%.
Right.
And again, I do the same thing here with the same thing I do with the validation sample. See whether there is null value here. I'll say so I have some problem here. I'll sort it out. Let me go back to the presentation now. We had done the WOE transformation, right?
Right.
Yeah. So you can reduce the variable before or after grouping. When you do the correlation analysis, it's better to do it after grouping, which means after you have made the attribute and then you do the WOE transformation, you can group after that also. There's a procedure called Verclus in SAS, which help you to draw variables because it creates clusters, and you pick one variable from each cluster.
So that would be similar to the PCA, right?
Very similar to PCA, but not exactly PCA.
Okay. Okay.
Yeah.
Basically, it will not create a new values, but it will just help me to reduce the other variables and just pick one with the same values, right? So this would be the difference.
Yes.
Got it. Got it. Sure. Thank you. Thank you.
So this is a better approach for choosing the variable for regression. It takes care of collinearity as well as correlation. So I have put the graph here, which basically I just shared with you guys.
So actually, one more question here. Actually, many times I have faced one question from the like the, you can say that the auditors. So they ask, like, whenever we use any SAS procedure, so we actually don't know what is happening behind that procedure. So like we have many other procedures as well. Like in logistic also, there are multiple functionality that we can reduce the variables also. But they ask, okay, what exactly is happening in that particular procedure? We actually don't know about it. So here also, when we talk about the workless, so it drops basically multiple variable and it keeps one variable from a group of clusters. So, but actually we also don't know what is happening behind that. So how to like address those kind of queries?
Thing is, the kind of query you have, you need to really get into SAS documentation.
Mm-hmm.
And after reading the SAS documentation, you need to figure out how Verclus is working. And then you can answer those questions. Suppose it has something called 1 minus R square values.
Mm-hmm. Right.
And then 1 minus R square value, or better to do the SAS course, predictive modeling using logistic regression.
Mm-hmm.
Because I had done that course a long time back.
Okay.
And that course will give you the detail of what's actually happening inside the Verclus.
Got it. Okay, thank you.
So now we'll talk about class imbalance. So we have so many non-event. We have only this much event. So event is only 7% of the sample. So class is imbalanced, which means we need to do something either oversampling or undersampling. In the oversampling, you reduce the non-event. In the undersampling, you increase the event, right? So this is how undersampling look like. This is how oversampling look like. In the undersampling, original data set is this, and I reduce the non-event here to bring it to this level. In the oversampling, what you do is you add sample to minority class, make it equal to this one. This is how oversampling is done. If you look at in Python, there is a very good procedure where you specify a variable called class weight. When you specify class weight is equal to balance, then it will do the oversampling, and it will give very good result. So you can specify class weight is equal to balance in logistic regression, decision tree, random forest, gradient boost, and SVC, this is vector machine. There is something called SMOTE. SMOTE is another example of oversampling. It creates sample by interpolation. So there are existing observations, and you basically on equidistance you will create a sample with the event. This kind of oversampling will increase the event rate. Same point of time, it will remove the duplication. So how it's done in Python is you create an instance of SMOTE. After creating a SMOTE of SMOTE, instance of SMOTE, you do the fit. It will increase the event here. When you say the SM.fit resample, after that you see the distribution shape of the SMOTE. We have nearly 14,000 events, 14,000 observation, but new sample has 33,688 sample observation. Do you notice the difference? And you will use these two oversampled data X SMOTE, Y SMOTE for fitting the logistic regression.
So we will be using SMOTE if we don't use that balanced
Right.
attribute there. Okay.
I
Yeah.
had tested it. This particular thing and this particular thing use similar result.
Okay. Again, I have another follow-up question, which is it will be natural to that the default event will be less than the non-default event, and for that every time we need to do this kind of oversampling or undersampling, or I mean, can we think about something like as it is naturally occurring, so can we do whatever data is coming in and build our model on top of that?
No, we cannot do that because your AUC will drop, accuracy will drop. If
Okay.
your AC dropped, accuracy is dropped, there is no point in making model. Until unless you have accuracy of 75% in behavior scorecard and 70% in application scorecard, it does not make sense to make a scorecard. Is this clear?
Yes.
Okay.
So
Okay.
what are the class weight is equals to balance does in the algorithm?
It will do this
Either it will either undersampling or over.
oversampling.
Okay, it will do oversampling only.
Yes.
Okay, okay.
Okay. So we will talk about logistic regression little bit. So logistic regression, I think you are using day and night. Can anybody define logistic regression? Anyone?
So, uh, so yeah. So I guess we are trying to predict, the odds of any event happening through a logic equation, and I guess that is a linear equation, like it have the all the betas and alphas with it.
Mm-hmm.
Or in other words, from the odds of the event, we can transform it and find the probability.
Okay.
So
It sounds good.
maybe I
What you
can.
said is good. Anybody else?
So it is a method basically to predict the probability for the supervised learning. So where we have the like the dependent variable defined in a discrete way. So it would help us to do that.
Okay.
Yes. So in logistic regression, the equation we use is the sigmoid function, and it is used to predict the discrete outcomes.
Mm-hmm. Nice. Okay. So let's say logistic regression is the main method for predicting the score. So far, we are using logistic regression for building all scorecard, and mostly it's used in fraud application as well. And the equation, which basically is the central equation for this particular logistic regression, is this one, where probability of default, which is again like a score, is a logic transformation. This is a transformation which is the key here. This indicates probability of default. I have said it by P. And these are the coefficient of your logistic regression. It will give us probability of default. When you apply the log odds here, which is minus P minus over 1P, it will become like this. A simple score. It's a linear combination of all the variables and their coefficient. This score represents log odds, which means log into P over 1 minus P. This odd is ratio of probability of default divided by probability of non-default. So logic transformation is the log of the odds. It's used to linearize the probability and limit the outcome between 0 and 1. Maximum likelihood is used to estimate the parameters. Parameter estimate indicate if you change one unit, one variable, how much value will change of the logic. Target in logistic regression is binary. It could be multi-class also when you use the wholesale banking. Input variable basically are the variable which basically you pass as a value. You can pass as a raw data or you can pass group data, the kind of data which we have. And we have dummy variables also. In case you don't do WOE transformation of the categorical variable, it will create dummy variable for each categorical variable. But if you do WOE transformation, then I think it helps you in giving result in scorecard format. There are three techniques to run logistic regression: forward selection, backward selection, and stepwise. Stepwise regression. In forward selection, you add one value at a time. In backward, you add everything and you remove one value at a time. In stepwise, you add and remove one value at a time and see how it goes. Anybody, any question? So let me go back to here. Let me run this. So we're going to run logistic regression here and see the result. So we take all the variable other than target variable into train, and we take the target variable into Y train. Same thing we do with the validation, and we see the same. We have create an instance of logistic regression, decision tree, random forest, gradient boost, SVC, KNN. And then we run it. Actually, I'm losing the data here. So I need to drop some values. I'll fix this code later. Let's run it. Here I lost some data here. And some data here. So it's not giving the kind of result which I have here. So we get 78% ROC and 79% accuracy. And we have accuracy, precision, recall, FN score, ROC, Gini coefficient. Are you guys following me?
Yeah, yes.
Yes, please go ahead.
Okay. Shall we go into theory more or shall we cover tomorrow? What do you say? Because we are already more than half the way.
I am liking whatever the way things are, going on for now. So a balanced way, theory and
So, sir, like what all sections are remaining? I think you're on mute, sir.
Sorry. So we have logistic regression, different modeling technique, row probability to behavior score application score mapping, confusion matrix, AUC determination, optimal cutoff, cutoff determination, left chart, and then front-end report, benchmarking, then result of the scorecard, application scorecard. So what is, shall we stop here and continue tomorrow at same time? Because there is some problem with my code, which I had to fix. Because this result, which I just got here, I'm not happy with them.
sure. I mean,
Okay, sir. Yeah, we can do
Yeah.
tomorrow, same time.
Yes. Yes.
Okay. So let's do it tomorrow. And I hope to see you all tomorrow. And we will, you have the data, right?
Yes.
Yes.
Everyone.
Sir, yes, sir. Sir, can you please share the PPT as well so that at least we can revise the starting step, if possible?
Right.
PPT, I cannot share because it's a consulting PPT of the company. And everything is from the Naeem Siddiqui.
Because it has got so many kind of rules in data preparation. So
I'm going to
that's
share
why I was
this.
asking.
I'm going to share everything on YouTube within a week time.
Okay. Okay.
So
Okay.
all the discussion will be there in the YouTube.
Yes, but it would have been great if we also got the PPT.
Okay, let me discuss with my partner, then I'll come back to it.
Sure, sure. Thank you.
Okay, thank you very much.
Sir, one question actually.
Sure.
So actually, are we covering some Basel or IFRS 9 kind of modeling stuff?